Hi, I'm Carl Schultz, President of Packline Corporation and Packline Conveyors, Inc. Today I'd like to talk a little bit about power and free conveyors. Power and free conveyors are sometimes called asynchronous conveyors by virtue of the fact that the loads hanging from our conveyor can go at different paces. They can stop and go independently, and they can even change tracks when required. This can be very useful in certain processes. Where does it get its name from? Well, it gets its name from the track configuration. Here we have a powered chain running in the powered track above free trolleys which run in this lower track. If I show you the trolleys here, you'll get a better idea how this works. So these free trolleys, there's a front and a rear trolley here connected by a load bar. The load bar is there to provide separation between loads so that the loads won't hit each other, but also to give a better capacity. So the capacity of this would be 220 pounds and 220 pounds for a total of 440 pounds under this load bar. The construction of each one of these trolleys is 4 wheels with a pair of flippers on the top. There's a front flipper and a rear flipper. Now these flippers are the way that power will be transmitted from the powered chain through to the trolley. If I can go back up to this conveyor, on this powered chain above, you can see here when this conveyor gets exposed that there's a driving dog hanging down below. Well, that driving dog will actually come between the front and the rear trolleys. It'll sit in here, and it will actually propel that trolley forward. And then, of course, the rear trolley will follow it because it's attached by this load bar. The advantage of a power and free conveyor is that basically these trolley sets will act much like cars on a road. When you come up to a four-way stop, for example, first car will stop and all the other cars will pull up behind it and stop behind. When the first one leaves the stop, the others will pull up to the stop and line up behind each other. You can do this without any additional automation because it's basically there's a mechanical linkage here that causes loads to lose their power when desirable. This tail section on here is basically a small ramp upon which the front flipper of the next load coming up behind will ride. So it'll actually ride over that tail section, become flat, and it will not be pushed by the dog anymore. So we're going to show you that a little bit closer later on. So I like to think of power and free conveyors as a system of trains on train tracks. You can have parallel tracks with switches. You can have stops. These trains can stop and start wherever they like. They can merge, and that's very, very useful if you have a system, for example, a paint system where you have 3 paint booths and you don't want to be changing the colors all the time. So you're going to route your product into the appropriate paint booth, have work done on that product, and then afterwards merge into a single cure oven. So it's very useful in a number of different applications. The other advantage of power and free is that you can do a lot with only one motor. Quite often a small circuit of 200 or 300 feet will have only a single motor. Well, you might say, well, how does that happen? I've got my powered chain dog pushing this trolley down a track, and now it reaches a diverge point. Basically, it reaches a Y in the train track. How does it continue to push in 2 directions? Well, as you can see here, this powered chain will be introduced at this section, which is actually a track switch. So we have a powered chain that comes in and another one on the inside that's coming straight through. They're configured much like an X, where one comes in from the side and takes over the load. And that's why this circuit is quite a bit more complex than you think. If we take a look from above, you'd see that there's a lot more powered chain in this system than meets the eye at first. So the features of the conveyor, which we're going to look at more carefully now, are the switches and the stops. Okay, let me describe how a stop works. On this test loop, I have a simple toggle switch arrangement to release stops. I have a stop on the back line, and I have two loads lined up. There's two load bars. They're different because they were for different projects, but when I open up this toggle switch, an air-activated stop opens, and the first load is conveyed through the stop. So that load is coming around the corner now, and I've re-engaged the stop, and the load behind it is stopped until I send a signal to open again. So as it comes around, we'll have a look at how the dog acts against the flippers, the front flipper, to push this load. So now you can see the dog is between the two flippers, and it's pushing it along here. So basically what a stop does, a stop makes the front flipper move out of the way. When the stop opens, flipper comes up, and the next dog in our powered chain comes along and pushes that load forward again. Similarly, at switches, the front flipper needs to be in contact with this driving dog so that it can propel it through a switch area. And that's where we get actually two powered chains coming side by side. So if I can just sort of show you with my hands here. We've got a dog coming from one side, a dog coming from the other side. They come very close together. You'll actually have two dogs pushing behind this flipper, and one can then go off and do something else while the trolley is propelled through that switch area. In the switch area, I have a switch down at the other end. Basically, at a Y, we have a tongue which directs the trolley one way or the other. And it's on a pneumatic device that makes it move to the sides. If I activate that, the trolley is going to go in the path that I want it to go. Almost all power and free conveyors have a higher level of intelligence. They either have a programmable logic controller, which is basically industrial automation. It's an industrial computer that makes it do what you want it to do. There are a lot of sensors that go on the conveyor. You have to know that you're not going to have a collision between two loads at a merge section, for example. You may have prescribed a set time that a load has to stay in an operation, for example, in a cure oven before it gets released. These are all things that are programmed into that industrial computer. You can even go the next step, which is a PC controller, which it can handle databases and all sorts of other things. So it's quite common that for each load placed on a power and free conveyor, there's an identifier. It can be either a barcode or an RFID tag, and that will carry the instructions on what's to be done with that load. Each one of our conveyors, of course, has a drive unit down at the other end. That drive unit will have some controls attached to it. It'll have a pulse indicator so that we know that the conveyor's engaged. It'll have torque limiters and a few other sensors on it. At each stop, we would normally have sensors to detect that there's a part present at the stop. We would also try to prevent the overloading of a particular zone by having a line full sensor. And those are all devices that we would design into your system. So those are the basics of power and free conveying. Give us a call if you have a power and free application, and we'll get one of our engineers to help you out promptly. Thank you.